What's up, everybody? Welcome back to another another live stream from Scalar Learning. And it's Sunday, so we are, of course, tackling SAT problems, math problems from Khan Academy, from the source. So again, if you're prepping for an upcoming SAT, make sure to tune in every Saturday and Sunday at 7 a.m. And today we are looking at function notation problems. So function notation problems, and as always, if you're new to the live streams and new to the channel, when I do these problems, I'm doing them for the first time. I have had no preparation, so I haven't seen them before, and that's the point. I want you to get an authentic sense of what it's like to solve these problems in real time. All right, here we go. Consider the following table. So we got the variable x, and we got these two functions. What is the value of f of g of 2? All right, look, check this out. We're trying to find f of g of 2. This is actually a really easy problem if you know what they're asking. So when we have problems like this, we always work from the inside out. Okay, so we're starting with this quantity before we even deal with the f. So let's bring this down here and say we just want g of 2. What they're saying is they want the value of the function g. Here are all my values of function g right here. They want the value of function g when this term, my x term, right, because this is g of x, when the x term is 2. All right, so basically we're plugging 2 in for g of x. Look at the table here. Here's where x equals 2. This, therefore, is g of 2. This is where we're plugging in 2 for x into g of x right there. Therefore, g of 2 happens to be 2. Okay, now we know that g of 2 is 2. So now we're plugging that in here for this quantity, okay? So which means we're now taking f of 2 because g of 2 equals 2, and now we're taking f of 2. So what does f of 2 equal? Well, now we go back to the table again. We say here's 2. What is f of 2? Here's all the values of f of x. F of 2 is right here, is 3. And there we go. Boom. All right, next. The graph of y equals f of x can be shifted 3 units in the positive x direction and 3 units in the positive y direction to obtain the graph y equals h of x, okay? If f of x equals 4x plus 10 and h of x equals this, what must the value of a and b be? All right, so check this out. This requires you to know a little bit about transformations, and I can explain it as follows. So we're taking our original function, f of x equals 4x plus 10, okay? And then they said to get to h of x, we need to shift this 3 units to the right. That's 3 units in the positive direction on the x-axis and 3 units up, okay? So let's deal with both these individually. First of all, 3 units up, that's pretty easy to represent. All we're doing is we're just adding, actually, let's just go straight to this function. No, actually, I'll do it down here. We're just adding 3 on to this entire thing. And I'm going to say, so we're adding 3 to this 10. So it just becomes plus 13. Okay, I'm going to make some room and you'll see why in a second. Now I have to deal with this. So we've already dealt with the 3 up. Now I have to deal with the 3 to the right. When we shift to the right or left horizontally, we're affecting the x directly. Okay, so what does that mean? That means that, put a little parenthesis here, let me move this over. It means that we tack on a number to the x, sort of like within these parentheses. So right now we have a multiplier and everything, so we have to kind of bracket it and apply whatever change, you know what I mean? So like we're multiplying this whole thing by 4, so we're applying the horizontal change within this scope. So the horizontal change is also being affected by that 4. All right. So we want to shift it 3 units to the right. Now you may think that because it's 3 units to the right, just like 3 units up, we did plus 3 units to the right, we're also adding. That's actually not the case. We're actually doing the opposite of that. So when we're moving 3 units to the right, we're subtracting. So it's 4 times x minus 3 plus 13. And this will give us the shift that we want. But then they say, what must the value of b be? And they're putting it in this format, ax plus b. That's not the format right now. What we have to do then is we have to distribute. So we distribute f of x equals 4x minus 12 plus 13. Negative 12 and 13 give us 1. So boom, and my value of b is 1. All right. Next. Okay, the graph of y of h of x is at the left. You know what I'm going to do is I'm going to take this here and just take a screenshot. Just so we can see this a little better. Okay, the graph of y equals h of x is shown here at the right actually now. It is true that f of x equals, so this is 1/2. It is true that f of x equals 1/2 of this whole deal, which the following represents the graph of y equals f of x. So they're applying these transformations to whatever this function is. So they're doing a few things. They're multiplying this inner term by 1/2. They're multiplying this exterior part by 1/2, and then they're also making it negative. Now, when we multiply something like this by 1/2, that is going to be a horizontal stretch. Okay, if this number was greater than 1, you don't have to remember all these different nuances. I think have them so well memorized, but like you can even test it out. If you're ever confused, a great way to test it out is if you say y equals x squared, right? So we kind of look at this function, and then this is what y equals x squared looks like roughly. And then if it was y equals 4x squared, right? Every value is then multiplied by 4. So when it was, instead of being 1 here, it'd be 4, right? Because 1 squared, if I plugged in 1 squared, it'd be 1 times 4 is 4. 2 squared, so normally it's 4, but now it's 2 squared, 4 times 4 is 16. So this next value would be really up high. So you can immediately see that the value of 4, it's like compressing it, but it's really like a vertical stretch. It's lengthening it. So we remember that, but when it's between 0 and 1, it's the opposite. It pushes it out. Because if I did y equals 1/2 x squared, it's normally it would be 1 here for 1, but now it's 1/2. For 2, it'd be 4, but now it's 2. 3, it was supposed to be 9, but now it's 4.5, right? So you can see it gets kind of like that, flattens out. So that's what's happening in this case, right? So that's what the 1/2 is doing. It's flattening it out. And then we've got to deal with all this stuff. So when we're talking about a 1/2 within the x, we're talking about, hold on, that one is the opposite. If we deal with a number greater than 1, it becomes, it's like the reverse. So if we deal with a number greater than 1 in here, it's the equivalent of it's a horizontal stretch. So it'd be stretched out, sort of like this. It would be in terms of a vertical compression, but it's not. It's a half. So this guy is going to be a vertical stretch. So I think these two are kind of going opposite each other. I'm going to have to plot it out and make sure that makes sense. But the negative, this is going to be the most important. So because we have a negative applied to the x, if it were a negative applied to the entire function, we'd be flipping it across the x-axis. But instead, this is a flip across the y-axis. So the most important thing here that we have to realize is that this thing is going to be it's going to go like that, all right? So it's going to have some compression things that are happening, but most importantly, it's going to be flipped across the y-axis. Nothing else is going to shift it, and it should still cross. Let me just make sure for a second here. It should still cross at 1, something. I think it should still cross at this exact point. I don't think that's going to be modified. Maybe then it comes down and hits the 1/2 because we're we're compressing everything. So it's going to so let's do that. It's going to cross here now, and it's going to be something like this. All right, now let's look at our answer choices and see which one we can kind of figure out. So see, that's a flip over the y-axis. It's applying those compressions, like we said, but it's not going to flip over it's flipped over the x-axis. That looks wrong. Again, same deal. This is looking more like my right answer, right? It's flipped over. However, And you see how they're both going over around 1/2. So this seems to make more sense, the most sense, because it's been like flattened out. Otherwise, this one, like I definitely know that 1/2 value is supposed to flatten it down. I can't remember. The thing is, I can't totally remember if the 1/2 applied to the x does the same thing. But I can. Hold on, let me think about it for a second. I can figure it out this way: y equals 1/2 x squared. Yeah, it'd be the same thing. Actually, I can already tell, because if I plugged in, it would actually just be a more aggressive flattening. So it's gotta be d, because if I squared this one, it would amount to the same thing. It would just be like 1/2 x squared, 1/4 x squared. So it'd be even more of a push down, right? Like 1/4 versus 1/2. It's compressing it even more. So I think D is not D. Yeah, I think D is the play. Let's see if I'm right here. Yeah, cool. That's it. And see, here's the stretch in the x direction, or we say a horizontal stretch versus a vertical stretch. And then they'll talk about that h over 2. That's the reflection over the x. Oh, you know what? They don't even talk about that 2. Hold on, let me see if they do anywhere. Oh, here we go. Where k is a positive constant is the graph of fx scaled in the x direction by a factor of 1 over k. Yeah, exactly. So it's sort of like two horizontal stretches, both acting on it simultaneously, which is why it gets so flattened out. All right, cool. See, I didn't have it all totally have it completely memorized for all those transformations, but you can figure it out. Next, functions p of x and w of x are graphed in the xy plane. The graph of p of x is equivalent to the graph of w of x. So p of x is equivalent to w of x. I got it. So if w of x is translated 4 units up and 3. So it's like this. We'd say, I get it now. P of x is the same as w of x translated 3 units to the left and 4 units up. Okay, so I'm just getting an equivalent thing here. I'm setting it up, and you can see actually that's all they want you to do, right? So where positive x direction, the right, positive y direction is upward, which relates the following. Oh, wait a minute. Did I do it backwards? Hold on. Let me read this again. The graph of p of x is equivalent to y of x. Translated, w of x translated 4 units up. So if that one, yeah, see, I'm reading it backwards. So like, I suppose this might be the answer, but I have to think about it a little bit longer. Because if I read it correctly, it might be this. You see? Because I'm reading it as like, hey, w of x is this guy. Oh, wait. Let me read it one more time. Graph of p of x is equivalent to this function when it's translated 4 units up and 3 units to the left, which is what I have here. P of x is equivalent to that, right? It's equivalent to the graph of wx. Yeah, see, like I feel like the way they phrased it is not the best because it's confusing. I can't tell if they're saying p of x when translated 4 units up and 3 units to the left is equivalent to w of x, right? Or if they're saying p of x is equivalent to w of x when w of x is translated 4 units up and 3 units to the left. And sometimes I see this with the Khan Academy questions. They're a little bit vague. You usually won't ever see this on an actual SAT or College Board test. So that's where I'm getting confused. So if that's the case, if I am reading it correctly like I thought, right, this would be right. P of x is equivalent to that one translated that way, which means that like let's say this is P of x and W of x is down here, right? Because it's 3 units. Sorry. It'd be like this. P of x would be like this. And then w of x would be like this. So basically we translate it 3 units to the left, and then 4 units up, and it would be the same as p of x, right? We'd kind of map it over that way. If that's the case, if I'm reading it correctly, then that means w of x equals p of x when p of x is translated, what is it, 3 units to the right and 4 units down. You see what I'm saying? So I'm almost leaning towards this one now as the right answer. Again, it's a matter of interpretation. Let's go for it. But I know if what I'm saying is that if this ends up being incorrect, it's just because it's almost like the grammar is incorrect, right? Like I can't tell what this is relating to. You know, if it's relating to, because I just feel like if this is right, it's a lot. It's a lot of work to do because you have to visualize it, and then you have to apply the opposite of what they're saying to the functions to make the translations correct. Let's see if it's right. I bet it is right. See that to me is so then, which means that I did read it correctly, but they really made it a hard problem. I don't think you'll ever get something that difficult on the actual SAT. I think mostly they'll be just wanting you to apply the transformations, not do it in reverse. You see what I'm saying? Let's see. P of x is the graph of this. Yeah, so I did read it correctly. Of this one translated 4 units, blah, blah. See, so they didn't like start with this and then come to this, but okay. This right word corresponds to -3. Right and downward translation. Okay, anyways, pretty tricky question. Last one. I'm going to do the same thing. I'm going to take a screenshot of this so we can read the question simultaneously. Okay. Okay. The graph of y equals negative f of negative x is shown at the left. For which value of x is it true that regular f of x equals 1? Okay. What they're saying is that this has been shifted twice, or the 2 negatives have been applied, right? It's like negative, okay, visually what that means is it was shifted over the x-axis and over the y-axis. So hold on, let me see if I can figure this out, how to graph the correct way. So it was like this and like this. And at -4 it is, so it's like down here. Try to graph a few points here. Okay. So the first shift is like this, right? Oops, hold on. Let's get it really precise. Boom. Okay, so that would be a shift over the y-axis, and then it was shifted over the x-axis. So now this would come up here. Let's do it in red. This would come up here and be like boom, right? And then this would come down here, -3. And then it goes up to -5 or something. Okay, so there's the function. There's that red would be the original function. And we could have flipped it that way and that way. It doesn't matter. The order of the flips, it doesn't matter. But this is our original function, f of x. Now, for which value of x is it true that f of x equals 1? It's probably going to be somewhere around here. Like when x equals 2 is what it looks like. I'm trying to see if there's a way to do this algebraically instead of graphically. So in this case, we want to know where it's going to equal x, -x, and we want to know, so let me just think about it for a second. -x, so when it goes back to the regular, we want the opposite of that. So I'm saying, okay, so first of all, let me say what my answer is based on the graph. I think it's like, I'm saying x equals 2, right? Okay, so in this case, in the original function, we plug in -2, we get -1, right? So that means in the regular function, yeah, that actually makes sense. Because look, check it out. Here we plug in -2, and that's like plugging in +2, right? Because the negative negates it. And then that gives you probably +1 because then it's negated again. That gives you the -1, which means for the regular function, if we're just plugging in regular 2, right, we're still getting a +1, but without that negative, which makes it a +1. So that makes sense. 2 should be definitely correct. And then I did this graphically just to show you guys, but it seems to match up with what we worked out. So that seems right. All right, cool. X equal to 1. Yeah, okay. The definition or that explanation doesn't seem great to me, but hopefully mine was reasonable and hopefully that made sense to you guys. These are very hard problems, guys. These are, again, I think the most difficult of the function notation problems, and honestly, I don't even think you'll get anything as difficult as any of the problems. Maybe the first one or second one, but not some of these last 3 that are just extremely difficult. So I wouldn't sweat it too much. Hopefully that made sense. If you have any questions, make sure to leave the questions in the comments section. If you like the video, click that like button. And last but not least, if you want to see more from the Scalar Learning channel, make sure to click the subscribe button. If you're prepping for the SAT, we got SAT videos coming out every Saturday and Sunday at 7 a.m. PST. I'm going to quickly just make sure we don't have any questions. And if we are good to go, oh, we got a few. Hey, okay, 1170 in 2 months prep. Oh, wow. That's pretty solid, Tanish. So, all right. If you've got about a month and a half, like a month and a half or a month left, that's hard. Right. And I also need to know your breakdowns in terms of the verbal and math. All I can say is in terms of your math, you definitely have room to expand that score quite a bit. You know, I would just make that your #1 priority. I would just be crushing math problems on the regular. Get through as many of these Khan Academy practice problems as possible. I have a video course as well that's available for sale. You can look in the link below, in the description below, and you can get a 50% coupon if you want to buy that and use that for practice. There I have a ton of, I think I have like 700 practice problems. And in addition to that, I have video explanations for every single one. So you can check that out as well. I'm planning to take the March one as well, guys. I'm scoring the low to mid 700s for math. My goal is to go above 780. That is easy if you can problem solve and make connections. All right, look, so CRS Blade, here's the thing. If you get better at problem solving, all right, my thing is, I mean, that's why I make these videos. These videos, especially my Khan Academy SAT problem ones, I would watch a ton of those because most of them are the really high level, very difficult problems. Watch my process in terms of how I work things out, especially when, even today, hopefully you saw a couple where I wasn't totally sure, but I was able to reason through and still get the right answer for all of these. So definitely I would watch as many of these as you can, binge watch them, and then keep practicing as much as possible. That's going to be the only way to, especially if you're trying to get the harder level problems, that's going to be the ultimate way to make those connections. My SAT score was, I got a 1540 the last 2 times I took it. And when I took it in June, I think it was like of 2016, I got 800 math, which is perfect, and then a verbal of 740. Then I took it again in October. I got one question wrong, made a really stupid mistake, but I got a 790 math and then a 750 verbal. So it ended up being the same score both times. All right, guys, hope I answered all your questions. Thank you so much for joining, and I'll see you all next time. Take it easy.